Welcome back. The topic of this interactive video lesson is midpoints, medians, and diagonals of polygons. Let's start by talking about the triangle midsegment. This is triangle ABC. Each side of the triangle has a midpoint. The midpoint divides the side into two segments of equal length. Segments drawn between two midpoints are called midsegments. Notice we can measure the degree of each angle, and we can see the midsegment of two sides is parallel to the third side of the triangle, and it is half as long as the third side. So we see that line segment DE is parallel to line segment AC, and the measurement of line segment DE is half of the measurement of line segment AC. Also, line segment EF is parallel to line segment AB, and the measurement of line segment EF is half of the measurement of line segment AB. Likewise, line segment DF is parallel to line segment BC, and the measurement of line segment DF is half the measurement of line segment BC. Now let's talk about measuring the triangle midsegment. Is D the midpoint of line segment AC? Well, let's measure, and we see that yes, in fact it is. Is E the midpoint of line segment AB? Again, we'll measure, and we see that yes, it is. So is line segment DE parallel to line segment BC? Looking at the measurement of the angles, we see that the measurements are equivalent. So yes, line segment DE is parallel to line segment BC. So is the measurement of line segment DE equal to the measurement of line segment BC divided by 2? We measure, and measure again, and we can see that yes, it is. So look at this animation. Notice the length of line segment AB is 9.2. It doesn't change. However, the length of line segment BC does change. Now, if we know that line segment DE is the midsegment of line segments AB and BC, and also that line segment BF is a median of triangle ABC, then does the midsegment DE always bisect the median BF? When is the median congruent to the altitude? Look at this animation and see if you can answer these questions. So on the first one, yes, midsegment DE always bisects the median BF. And for the second question, the answer is when triangle ABC is an isosceles triangle. This is when the median is congruent to the altitude. Note, a median that is congruent to the altitude is also called a right bisector. Notice it forms a right angle. Let's talk about an application of this concept. We'll use an A-frame cabin. The dimensions of an A-frame cabin are shown in the diagram. The main floor has a width of 6 meters. The main floor ceiling has a height of 2.6 meters. What is the width of the second floor? Well, here we see that it's 3 meters. What's the height of the ceiling on the second floor? Well, we can see that it's also 2.6 meters. We know this because this is an isosceles triangle, and the second floor is the midpoint of the sides of the house. Now let's talk about the median, altitude, and area of a triangle. The median of a triangle is a line segment that connects a vertex to the midpoint of the opposite side. As seen here. The altitude of a triangle is the perpendicular line segment that connects a vertex to the opposite side. So the altitude equals the height. So if we found a right angle and drew a line straight up, there we go. The area of a triangle is 1/2 of the base times the height. So the length of the base here is 6 centimeters, and the height is 3.4 centimeters. So 1/2 times 6 centimeters times 3.4 centimeters is 10.2 centimeters squared. Now the median of a triangle divides it into 2 new triangles of equal area. We'll again take the same measurements. The base and height of the green triangle is, the base is 3 centimeters and the height is 3.4 centimeters. The base and height of the yellow triangle is also 3 centimeters and 3.4 centimeters. So finding the area, we see they're both 5.1 square centimeters. Let's explore the median, altitude, and area with this animation. Notice here's the height. Here we have the base and the area of the green triangles. Here we have the base and the area of the yellow triangles. Does the median of a triangle always divide it into two new triangles of equal area? Yes, it does. The median of a right triangle, shown below, bisects the right angle. In other words, it divides the 90-degree angle into two 45-degree angles. So we know the measurement of angle ABD is equal to the measurement of angle DBC, which is 45 degrees. Does the median of a right triangle always bisect the right angle? If not, find a counterexample. Let's look at this animation. Notice this would be a counterexample that shows that we have a median bisecting a right angle, and we see the measurement of angle ABD is not equal to the measurement of angle DBC. However, they are complementary. So the median of a right triangle does not always bisect the right angle. Now let's talk about how to determine if something is a parallelogram. If the opposite sides are parallel, the quadrilateral is a parallelogram. However, in a previous lesson, we learned a few other useful relationships that parallelograms have. For example, if the opposite sides are congruent, then the quadrilateral is a parallelogram. If the opposite angles are congruent, the quadrilateral is a parallelogram. If one angle is supplementary to both consecutive angles, then the quadrilateral is a parallelogram. And if the diagonals bisect each other, then the quadrilateral is a parallelogram. Now let's look at the midsegments of a quadrilateral. The midpoints of quadrilateral A, B, C, D, shown in black, are connected with midsegments to form a new quadrilateral, shown in blue. The angles of the new quadrilateral are labeled 1 through 4, and their measures are shown. After viewing this animation, form a conjecture about any quadrilateral formed by the midsegments of another quadrilateral. Do you notice something about angles 2 and 4? And then about angles 1 and 3? How about now? The midsegments of a quadrilateral form a parallelogram. Now let's look at an animation on the diagonals of a parallelogram. Parallelogram ABCD is shown at the right. Diagonals AC and BD are also shown. After observing the animation, draw a conjecture about the diagonals of a parallelogram. Notice the diagonals of a parallelogram bisect each other. So conjecture, the diagonals of a parallelogram always form a right angle. Use the animation to determine if the conjecture is true or false. Notice this is clearly false. Now let's look at the diagonals of a rhombus. Our conjecture is that the diagonals of a rhombus always form a right angle. Use the animation to determine if the conjecture is true or false. Notice the angles are staying at 90 degrees. So this is true. All right, now we're ready to do some more challenging examples.